Welcome to our explainer. Today, we are exploring a really fascinating historical coincidence. We're going to see how one single date on the calendar connects brilliant minds who literally built the technology we use every single day. It's like a giant puzzle, and it all starts with August 1st, a truly golden day in math history. Let's get right into it. We are grounding our entire detective story today on just this one date, August 1st. Now, you might be wondering what's so special about this day. Well, across entirely different centuries and continents, a series of breakthroughs happened on this exact date that forever altered our modern world. Looking at 1818, 1987, and 1992, the people sharing this exact date changed our world by asking the exact same fundamental questions about patterns and chaos. We're jumping from the early 19th century all the way to the dawn of the 90s. So, to kick things off, have you ever wondered how we can pinpoint and track objects in deep space? It's kind of like how your smartphone's GPS tracks you navigating through a massive, busy city today, but on a cosmic scale. How do we achieve that level of precision in the endless, completely chaotic night sky? The answer takes us back to August 1, 1818, and a brilliant observer named Maria Mitchell. Back in 1847, she observed the night skies so carefully that she actually discovered a telescopic comet before anyone else. But here's the really amazing part. Spotting it was just step one. She used complex mathematical equations to track its exact path through space. She calculated its exact right ascension and declination by establishing these celestial coordinates, which are basically the space equivalents of latitude and longitude. She proved that the seemingly unpredictable, chaotic heavens could absolutely be mapped. She famously said, "Nature made woman an observer, and the schools and schoolbooks have spoiled her." Her words are a powerful reminder for us today. The simple ability to just observe and find mathematical patterns in nature is without a doubt our greatest tool for discovery. Okay, still on August 1st, we're going to jump forward in time to 1987. We're moving from the telescope to the microchip, stepping into a completely different era and a brand new digital mystery. Think about when we use multiple apps at once on our phones today. You're streaming music, pulling up a map, getting messages, all at the same time. How does our device know how to handle all that invisible chaos without just freezing up and crashing? This brings us to Evelyn Nelson, who passed away on August 1, 1987, but whose mathematical genius absolutely lives on in the devices we hold right now. She took this concept called universal algebra and applied it directly to computer science. She created vital models for what we call non-deterministic computations. Basically, these are situations where a system has to handle multiple, unpredictable possibilities and inputs all at once. By building these theoretical math rules, she constructed the invisible architecture that keeps our modern software from crashing under pressure. Her brilliant work proves something pretty profound. Every seamless app on our phones is secretly resting on the rules of universal algebra. Behind every smooth, fluid piece of digital software is a rigid, hidden foundation of pure math. Moving right along, same exact date, just 5 years later, in 1992, we meet our final mathematician, someone who actively bridged the gap between human brains and computer algorithms. Imagine trying to calculate the math for a massive modern skyscraper. Actually, doing that heavy lifting entirely by hand could literally take a single human 100 years. So, how did we teach computers to do this unimaginable math for us? The answer to that lies with Leslie Fox, who passed away on August 1, 1992. Fox helped transition the entire world from incredibly slow hand calculations into the era of numerical linear algebra. He didn't just solve equations, he figured out the methodology for feeding massive, complex matrices into early computers. He essentially created the very algorithms that run our digital world today. He literally wrote the book on it. The algorithms running our modern world started out as equations in a textbook. Fox laid the absolute foundational groundwork for the heavy-duty engineering and architectural software that we rely on to build our cities every single day. So, let's take a step back. Every person we met today, despite living in totally different centuries, countries, and contexts, was connected by this one date, and really one overarching mission. They all looked at the universe and asked, what is the pattern hiding inside the chaos? And because they relentlessly pursued that answer, our world today has deep space tracking, flawless mobile apps, and immensely powerful engineering software. So I'll leave you with this. Where will you find the math in your world today? Next time you look up at the stars or even just open a map app on your phone, remember the invisible architecture making it all possible. The universe is always speaking in numbers. So what pattern will you discover today?